Alrighty, so there's one more thing actually that I was going to cover today. I forgot about it. And that is, how do we debug in parallel? And first off, I'm going to say that this is not an easy task. And there's a lot of ways to do it. First thing I want to talk about, CHPC has, let's see, where is it? If you go to documentation, programming guide, you'll see this debugging and profiling link here. Okay, that talks about how we debug stuff. And they have a total view. They have a license for total view, which is a parallel debugger. And here's their home page. And so I've played around with this. I've never used it before. They have a presentation here, and where they talk about it. And let's see here. So if you click the documentation link, yes, they have a video tutorial. Now, just so you know, this video tutorial is 5 gigabytes. And so, yeah, it'll take a while to download. And it's a little boring, just like me. But it'll go through how you actually use it. I didn't watch the whole thing. I just kind of pushed buttons and tried to figure out how it works. But they have some stuff on how to run it correctly. They do say if you're debugging stuff and you're using a few processors, they will allow you to work on the login nodes, or as they call them, the interactive nodes. And it seems to work pretty well. It's pretty cool. It's kind of ugly. It's got an ugly interface, but that's okay. We're engineers. We don't care what it looks like, right? And so that's, I did try it. It seemed to work pretty well. Unfortunately, I was not able to find my problem. But, so that's available to you. As long as, you can work on the login nodes as long as you're only using 2-3 processors max. Now, the way I've debugged this, and it's kind of ridiculous, but it works, is actually using GDB. So I have my example MPI code. Now, normally when you run this, you do something like this. MPI run, 2 processors, a.out. And it spits out, this is my hello world program. Now, for whatever reason, I want to debug this. You do the same thing, except I'm going to run a program called Terminator. Terminator is actually this terminal here. And then you give Terminator the -X flag, which tells it to execute a program. So it opens up and executes a program. And so what this is going to do, MPI run is going to run 2 copies of Terminator, and then the Terminator is going to run GDB, and GDB is going to run the program. Don't ask me how I found this. I don't even remember. You can do this. Most terminals have some sort of flag that lets you run a program as soon as you open it. And so if we do this, it's going to open up 2 Terminator windows, 1 for each process, and with GDB. And we can type R for run. You'll notice that side's not doing anything, and we have to type R for run over here, and then it runs through the program. The reason why this left one stopped is because it was waiting at MPI init. Everybody has to call MPI init and nothing. And so, anyway, you'll notice that this is actually really nice because it separates the output from each processor. You'll see rank 0 is over here, and rank 1 is over here in this window. And you can actually go ahead and run it again, and it does the exact same thing. However, you can now put in breakpoints. And well, that didn't really work out that well, but you can put breakpoints in it. It's kind of annoying because you have to do things twice if you want to have everybody stop at a given location. But that's how I've done all of my debugging, because a long time ago I never had access to total view. I may continue to play around with it because it looks pretty nice. But I'm definitely not an expert on it. But this is how I've done all my debugging in parallel so far. It's worked okay. It takes a long time. It's tedious, but that's debugging for you anyway. So go ahead and quit out of this. So anyway, that's how I've debugged in parallel. It's a lot easier than, in fact, you could do the same thing. If you want to separate the outputs, you can do the same thing just by doing this. Unfortunately, you need a way to pause your program, which is why using GDB is nice, because it pauses your program for you and keeps the windows from disappearing. But if you can have a way to pause your program at the end so the windows don't disappear, you can do that too, to separate the outputs if you're doing your cout printf debugging. So anyway, there's my little bitty parallel debugging overview. So good luck, everybody. Debugging in parallel is not easy, okay? So just be aware of that.